Good. Thank you. So, all right. So, this quiz number 3 will be soon available, in Brightspace after you get out of the class. Okay.
Okay.
So it's going to be solely on chapter 4, right? So about factoring stuff. That quiz should be a quick quiz, okay? But you have just like quiz number 1, quiz number 2. Do not open it until you are ready to do it, because once you open it, 40 minutes later you have to submit your test. You submit it in the assignment part, right? Just like quiz 1, quiz 2. Okay. All right. So and then that test number 3 will be later on. Okay. So today we're going to continue on chapter 5. Introduction to statistics, right? So organizing data, right? That's chapter 5. The last time we saw what was, qualitative data, or, categorical data. What was quantitative data, okay? So if it is quantitative, is it like, discrete, or is it continuous, right? So we saw that last time. So today we're going to see 5.2. These sections are very short sections, okay? The statistics part of this can be very, very short. So don't be surprised if sometimes they are very short. So section 5.2, organizing and graphing categorical data. Okay, so I'm gonna share my screen. Right, let me share my screen. Hopefully, uh, um, teams will not like play us like the last time, hopefully. So 5.2, organizing and graphing categorical data. Okay, this is the title. Okay, but first, before we do the bar graph, we're gonna do what you call frequency table, right? A frequency table, as the name indicates, frequency is how many times a data occurs. How many times we have, how many occurrences of a data. That is a frequency table. So as simple as that. So if we have this right here, this is my data right here. If this is my data right here,
Are you there? He left. He didn't want to teach us.
I think he got kicked out again.
He jinxed himself. He back.
yeah, I'm back. This is really puzzling to me, because I have like 2 classes, 2 virtual classes, one at 11:10, the other one at 12:30 or 12:45, and believe me, we run those classes with no problem at all. absolutely no problem. And when it comes right now, I don't know. It is like the Teams is saturated. I don't know what happens to this time, like 5 o'clock, you know. And unfortunately, you know, I don't want us to go back exactly, you know, back and forth between Zoom and Teams. So I hopefully it's gonna all right. But you know, I will keep now I know that it's gonna occur very likely. I will keep in, you know, I will keep in mind that I will always watch out the window, okay? See more than ever. Okay. So we were saying that is the orders, this data right here as the drink orders, okay, in a coffee shop. For an, you know 1 hour. So these are the data right here. This is a survey and this is what they got. So now a frequency table is a table where you put one column for the data and one column is how many times that data occurs, right? So one column for the data and one column for how many times we have that data. That is a frequency table. So if you do put this right here, okay, so you know, I have to do a better job drawing. If you do this, and we do this, that is a drink, and that is a frequency. So to do a frequency table, the only thing you have to watch out is to count exactly how many times you see that, okay? For instance, we see coffee, and then we have tea, and then we have espresso, and then we have soda. Do you have another type?
No, it looks like that's it.
So it looks like that is right, and then we just count. You see, so for the frequency, it's just counting. Now it can be annoying if you have like a data of 1,000 stuff, and then you have to count, you know, the frequencies. That can be very hard to do, right? But other than that, if you have a reasonable size data, if you have that, the frequency table is just to count how many times you have that, right? So right here, so the coffee, how many times you count for coffee?
16.
16. 1, 2, 3, 4, right? You know, 5, where's 5? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Is that 15? 16, right? You are right, 16. You see, coffee is 16. How many times we get tea?
10, I think.
Same, 1. I mean, you see row by row, 1, 2, 3, right? 4, 5, 6 right here, 7, 8, 9, 10, right? So tea is 10. How many times espresso?
5, 6, 7,
20.
8, 10, 11, 12, 13, 14, 15.
Is it 20, right? Is it 20?
Yes.
20 for espresso, and then soda is
3.
It's
3 or
4.
Oh,
4, right? Now, there's a way, you know, this stuff says, you know, we ask 50 customers, right? 50, they say in the 50 customers. So if they say 50 customers, right? One one way to check your answer is to add up the frequencies. When we add up the frequencies, we must find 50, right? That is one way to check your count. If is my count correct or not? So
Yeah.
So this is 50. You see. So I can do mistakes. You know, you can do mistakes. You know, you overcount here, you undercount here, but it is not likely. Okay. When you have the same number right there as your data, the size of your data, then this give you, you know, some type of assurance what you did is right. Okay, that is a frequency table. It's very, very, very important. So now you can add another row, another column here, where we say what we call the relative frequency. The relative frequency. No, because you know every time we wanna give you know a meaning to something. I think we have to see what is the relative count. You see, if it says a frequency, if it says 16, right? 16 people drink coffee. We cannot see exactly if it is like a large number or a small number if we don't know what is the size, right? You see, every number, you have to put it in context. When you put it in context, this gives an idea if the number is a big number or if the number is a small number. Outside the context, you cannot say, we cannot really say, you know, is 20 people who drink espresso too much? We don't know. You see, because we don't know what is exactly the size. We have to count exactly with the size. So the relative frequency help us for that. What is the relative frequency? Is the frequency divided by the size of the data. Relative frequency is equal to what? Is equal to frequency divided by the size of the data. For instance, for coffee, what is the relative frequency for coffee? Is 16 divided by 50. Okay, and then we take a calculator. If there is a decimal number, we can write a decimal number. So 16 divided by 50 is how much? When I take my calculator, 16 over 50, I get 0.32, right? Okay, this is 0.32. Now, sometimes they can ask you to give the relative frequency as a decimal number. In that case, we're done. But sometimes they can ask you to give it as a percentage, okay? Which is the same answer, by the way. Any decimal number, any number can be converted to a percent and vice versa. Any percent can be converted to a number. Remember, percent means divided by 100. That is percent. Percent divided by 100. So now if I have 0.32, what is the way to write this as a percentage? What we do? What operation we do to write 0.32 as a percentage? What do you think?
You divide.
0.32 is, we understand it is as a number, right? When you want to, if you want to convert it into a percentage, right? The sign percent right here, is that sign percent right here? You see, if I write this, I write percent. That sign percent means division by 100, right? What number you have to divide by 100 to get 0.32? You see, if you divide by 100, you have to compensate that. You have to compensate by multiplying by 100. Every time you want to convert a number to a percent, you have to multiply that number by 100, okay? To convert a number to become a percentage, you have to multiply that number by 100, okay? So you have to do 0.32 multiplied by 100, and then you can put percent, you see? Because these two, look, these two, they become what? They cancel each other, right? These two right here, what is 100%?
100%.
100% is what number exactly? Is
The
1,
hundredth
right?
place? Well, yeah.
100% is 1, right? When you say 100% is a unit, is 1. So they cancel each other. They become 1. So if you want to convert any number to become a percentage, you multiply by 100. Okay? So let me write it down. To convert a number to a percentage, multiply by 100. Okay? To convert a number to a percentage, what you do? Multiply by 100. Okay, so 0.32 becomes, this is when we multiply 0.32 by 100, it becomes 32 and then percent. You see? Can you do the same with the other ones? The relative frequencies of the other ones, can you do the same?
Are you there?
Yeah, I'm here. Can you do the same?
What numbers are you talking about? The frequency or the drinks?
No, the relative frequencies of everybody else. You see, we did coffee, right?
Uh-huh.
The relative frequency for coffee is 32%.
Oh.
Can you do the same thing with tea, espresso, soda, the three
Yeah,
remaining?
you could do the same thing.
Yeah, can you do that, and then we're gonna compare?
Oh, sure.
All right, for T, what we do to get the relative frequency of T? What we do?
Divided 10 by 50.
It's 10 by 50. Thank you. Which is 0. What?
0.2.
What percentage is that?
20%.
Exactly. We multiply 0.2 by 100, we get 20. It's 20%. For espresso is 20 over 50, right?
50.
Yeah.
0. What?
0.4.
0.4, which is
40%.
40%. That is absolutely correct. And now for soda, which is 4 over 50, which is
50.
0. What?
0.08.
0.08, which becomes what percent?
80%.
8%.
8%. Exactly. That is right. And when we add up the percentages, when we add them up, all of them, we should find 100%, right? 32 plus 20 is 52. 52 plus 40 is 92. And 92 plus 8 is 100%. So this is how we do the relative frequency. So now let me see if we got another one here, right? Okay, so now before we do that, so let me see. Okay, so let's talk first about the bar graph. How do we create a bar graph? Okay, so for instance, what you have here, how do we create a bar graph? I think,
Is there a way that you can maximize your screen so we can see it in full?
Is this screen right here?
Yeah, there you
Okay.
go.
So this is no, this is what is not good about sharing all my screen, because when I share all my screen, every time I click somewhere else, you know, you're going to be navigating, right? And that is a dilemma. The best thing is to share only this right here. Is to share the you know, the file. I mean the word file where I'm writing. That is the best. That is the best thing. For instance, this one. But when I do that, so we're gonna try again. When I do that is when the stuff get cut off. But we're gonna try, okay? Because that is the best way to share this. So you can see this screen right here, and when I navigate somewhere else to get something, so you don't have to move. Okay, so let me see. Okay, so now we're gonna do the bar graph. Okay, the bar graph of this data right here. This is the frequency. I think bar graph is not something, at least visually, is not something new for all of us. At least visually, you can see bar graphs almost everywhere, right? Everywhere you go, when you watch TV, you know, you see all type of statistics, stuff like that. So what is a bar graph? Basically, we're gonna do two sets of axes, this right here, and this. Keep in mind, since the data is not quantitative, since the data is only qualitative, it is a categorical data, this axis right here, we don't expect numbers here, right? We don't expect them. We don't have units on the horizontal axis, okay? This one here, no units, you see? Because, you know, how are you gonna put espresso as a unit, okay? How are you gonna put, you know, espresso as a unit? How are you gonna put soda as a unit, etc., etc.? So the horizontal one, the horizontal axis, we don't expect any numbers over there. Whatever is the data, this is what you're gonna represent. This one now, the vertical axis, we do expect, this is a number line. Okay, this is a number line. So we have to put some units, okay? Now, what is the size of the unit? You decide. Okay, if you know, for instance, the frequencies, you have up to 20 frequencies, 20, right? Then you cannot put like some big, you know, if you put this one, this is one, how are you going to fit 20 in this? You see? Everybody see that?
Yes.
So if you say one is here, 20 will be way, way, way above, right? So we don't need to put one. For instance, you can put here, this is 5, right? You can put this is 5. You can put this is 10. You can put this is 15. And you can put this is 20, right? But they have to be real units. They have to, you know, they have to have the same size, okay? Because you are ready to represent something. Now, you represent each data by a bar. That is why we call them bar graph. So for instance here, I'm representing, what is the first one? I'm representing coffee, right? Coffee, right? I represent coffee with a bar. The size of the bar, how large it should be, is my deciding. I decide how large it should be, but I have to be consistent. If this is the width of my bar, I have to keep the same width with all of them, right? I have to keep the same width with all of them. So now, coffee goes to, the frequency is 20, right? I mean 16. I go to 16. That's going to be 15, 16 is about here. My bar will go all the way to here. Right, that is my bar for coffee. See, that is 16 right here. And then I represent, say, next one is tea, right? Tea is here. I was saying we don't do that. Okay, even if the width, how large each bar is, has no meaning, you know, it doesn't mean anything. Because it doesn't mean anything, we have to try to represent everybody with the same size of bar when it's come to the width. Okay, why? Because it does not represent anything. Because the size doesn't mean anything. if the size meant something, then we would do, you know, we would do that. So T is 20, right? T is 10.
T is 10.
I'm sorry, T is 10. So we represent our bar like this. Same length, right? Same width, and go all the way to 10, like this, right? Okay. That is the bar for T. And then we go, next bar is espresso, right?
Mm-hmm.
We represent with another bar, same width, right? And then you go all the way to 20, right?
Mm-hmm.
So all the way to 20. See, that is the bar for espresso. And then soda, which is only for right here, it's going to be only this. That is what you call a bar graph. Okay, that's it. That is a bar graph. So now, I think if you have Excel, I think Excel can represent a lot of stuff. You know, Excel is a powerful tool, especially for statistics. Okay, so if you have data, you can represent, you know, graphs, you know, bar graphs, you know, etc., with Excel. But here, you know, we're not going all full gear with a. Okay, so this is a bar graph. Again, the horizontal axis represents the data, and the bar graph is mostly for categorical data. You know, mostly for categorical data. Or, you know, which is qualitative data. This is where we use the bar graph. For the quantitative data, we're going to use next. You're going to be what you call histogram. Okay, we're going to use what you call the histogram. But for qualitative data or categorical data, we use a bar graph, and this is how you're going to do it. Okay, so now what you're going to do is I'm going to give you another set here, and then you're going to try to do that. Do the frequency tables, the relative frequencies, and then try to draw the bar graph. Okay, so let me give you another one. So we have this one right here. Insert.
Did he go out again?
Yeah. I guess we'll wait.
Yep. This would be fun. Come on, go stop taking out my hand.
All right. You see, I was saying, so I let you try this. So now I know I have to share my whole screen. So I'm going to share the whole screen, not only one window. Okay, so you have this. This is a problem right here. That is the data. This table represents the data over there. Construct of frequency table, I said add also the relative frequencies. add relative frequencies column. So not only two columns, but 3 of them. So do this. So language, this is frequency, and this is relative frequency. Go ahead. I'm gonna let you 10 full minutes for everybody to try to do that from question A to question D, okay? Some full 10 minutes, everybody try to do that, please, thank you. All right, a couple of more minutes, and then we're gonna go over this. All right, so we have Java, right? We have Java. How many times do you have the answer Java? How many times the frequency?
9.
Everybody agrees with 9? I didn't count, Everybody agree with 9?
Yes.
Okay. Okay.
Yeah.
And how many times we have a Lisp?
3.
3.
3 times.
Mhm.
And then Perl?
12.
Ooh, I sorry, I counted 11.
12 or 11?
12.
12.
Mhm.
And then C++?
6.
6.
Oh, yeah, that's true. Yeah.
All right. So how many students participated in this survey? How many? So we can answer to the question C, right?
Yeah.
We have just add up the frequencies. How many?
30.
30?
Mhm.
Okay. We have 30 of them. Now the relative frequencies, I said the relative frequency for Java is what?
30%.
30%.
30% is 9 over 30, right?
Mhm.
Which is 30%. So 0.3, which is 30%. For Lisp,
10%.
10%.
exactly 0.1, which is 10%. For Perl,
40%.
40%.
is 0.4, which is 40%.
Mm-hmm.
And for C++,
20%.
20%.
0.2, which is 20%. Exactly. That is exactly correct. Now draw a frequency table now. So we can, just to be more do it more correctly, we're going to draw this, right? So we have Java here, we have a Lisp, we have Perl, and we have C++. So since I have my highest frequency is 12, here I can take,
3.
just like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So Java is 9. So it's going to be here. That is for Java, right? Lisp is, that is 9 right here. Lisp is 3. Right, that's for Lisp, okay? That is 3 right here. And then Perl is 12, which is like this. 12 is here. That is Perl, this is 12. And finally, C++ is 6. 4, 5, 6, C++ is about here, right? That is a bar graph, you see. No more, no less than that, okay? Of course, in the test, please, even if you do it on a free paper, try to have, something with some good units, okay? Sometimes when you ask students that, when you ask them, some students, don't take time to draw straight lines, right? You have to take a ruler, draw a straight line, make it a little bit nicer, okay? So when we grade, we feel good grading that, okay? All right. So now the next question now. Of course, draw a bar graph we did. How many students participated we did? We said 30 students, right? And then what % of students like C++?
20.
Can you answer to that?
20.
20, right?
Mm-hmm.
So what you did? That is a relative, to see what % of students like C++, we divide the number of people who like C++ by the total number of people. That is exactly the relative frequency. That is 20%, you see? And since they said what %, your answer must be a %. That is 20%, okay? Everybody see that? So what % of a student like C++? We divide the number of students who like C++ divided by the total number of students. That is exactly, by definition, that is the relative frequency, right? 20%. All right. You see, that is, how to represent categorical data, okay? So now we have another way to represent categorical data is what you call the pie chart, right? Everybody see that? Can you see my screen?
Yes.
Okay,
Yes.
this is what you call the pie chart. The pie chart is another way to represent categorical data. So let me have it right here so I can put some comment on it. That is a pie chart. That is another way to represent categorical data. So you have to draw a circle like a pizza or a pie, okay? And then you divide the pie into slices, okay? Into slices. Each slice will be as big as a percentage, all right? So the whole pie is 100%. You see, and usually we represent that, you know, the relative frequencies, okay, percentages, we represent them. But you know, they don't have to be only percentages. So now, if you don't, a circle is very hard to read, right? What are the only numbers? What are the only percentages that are easy to read in a circle?
The larger ones?
0% is easy to read, right?
Mhm.
What else is easy to read?
50%, 25%.
50%, right? 50% is easy to read.
The 25% and like 75%, right? Like all that.
Yeah, exactly. The quarters. You know, I think these are the only ones that are really, really easy to read. You know, if you draw the diagonal, I know it divides up 50%, 50%. If you draw one more diagonal, like 2, you have 4 quarters, right? Each quarter is a 25%. You see, that is the only stuff which is easy to read. Any other percentage is not very easy to read. So that is why putting the caption here, is almost not an option. We have to put it. If you don't put it, how can I look at this and know this is represented 32%? How? You know, it's not obvious, right? That is why you have to put the caption, the legend, you know, somewhere to tell us, to tell what are the percentages, okay? So, you know, except if you have some very, very nice numbers that we can read, okay? And then, you know, you see how we do it? In each slice, we exactly write what that slide, what data that slide represents. Coffee, we write coffee. Espresso, we write espresso, etc. And on the side, we write the numbers. If we don't write the numbers, we cannot see it. We cannot just read them like that. It's very hard. A circle is not like very easily like something else. That is another way to represent data, categorical data. Okay. All right. So let's see. Okay, so let's see this one right here. Everybody can see this?
No, I can't see the bottom of it. This one is.
Okay. So let me copy it and make it larger. All right. Insert this right here. Okay, so
That's better.
So here's the horizontal axis represents the day, and the other one represents the frequency. So the bar chart below describes the day of the week workers called in sick for workers at a company, right?
Friday is funny.
What is the relative frequency for Monday? Everybody go ahead. Take like a couple of minutes, do the calculations, and try to get the answer to that question. What is the relative frequency for Monday? I'll let you like a couple of minutes for everybody to try. All right, everybody. What is the relative frequency for Monday, right? Okay, so we know relative frequency, we divide two numbers, right?
Mm-hmm.
You want to divide the frequency by what number?
20. By
I tallied up all the columns and got 90. I
yeah,
wasn't
me too.
sure if I was right.
You got 90, thank you very much. That is the total number of workers. In this problem, we were not given the total number of workers like the other ones. The other ones, they said, you know, it was like, 50 stuff, 50, you know, customers. Here we are not given that. But when we add up the frequencies and the numbers are there, you see, they are nice here to tell you exactly what each number is, right? They are nice. They say this is 31. If they didn't write 31 here, then we have to go, you know, oh, okay, this looks like 31, etc., right? So we have to add up all of them, 31 plus 15 plus 9 plus 12 and plus 23. And you got 90, right?
Yes, sir.
We have 90 workers, right?
Mm-hmm.
So the relative frequency for Monday will be
25.
what divided by 20? 23
It would be 23.
divided by
90.
90, right?
Mm-hmm.
So now, since here they didn't say nothing about the format of the answer, they just say what is the relative frequency, you can leave it like that. You can write the decimal number if there is a decimal number. So 0.25555, right? You can write it is almost 0.256 when we round, right, up. Okay, or you can give your answer as a percentage, right?
Yep,
You can say
25%.
is 25, about 25.6%, right? Okay, so that is how we get the relative frequency. Again, now picture yourself having this stuff in a test, okay? So these are the questions in this section that we can ask in the test. Not harder, not easier, in this section right here. We're going to give you some set of data, and we're going to ask you to draw a bar graph, to do a table of frequency. I mean, to do in this order, we can ask you to do a table of frequency. We can ask you what is the relative frequency, and we're going to ask you to do a bar graph, and we're going to ask you this type of question: what percentage is using this, etc., etc. You see, these are the questions in this section that you can expect to get. All right, so not easier, not harder in this section. So let me see if you have another one. If it is another question. Okay, now this one here is a little bit. So let me copy it, and then we're gonna ask about it. Okay. Insert. I'm gonna insert this stuff. All right. Everybody can see this? Okay, so read this for yourself, the bar chart below, etc. Read it for yourself and try to answer this question by yourself. Okay, again, you know, I'll give you like 2-3 minutes for everybody.
Okay. So
Let me see your boat, Aiden. Okay. You're about to spill it. Bring it to me. I can't see it.
All right, so okay, everybody. So now, this one is a little bit different, right?
Mm-hmm.
How many donors have a blood group of O? How many? What's the answer you got?
I got 15.
You got 15? What
Yes.
did he do?
So it gave us how many people altogether donated. So it says 40. So I multiplied 40 and 0.375.
Exactly, right? This is exactly the right answer. Look, I don't know, for instance, how many people here. We don't know that, but we know if that number is X that I don't know, how many people, how many donors have a blood group of O? I don't know them. I call them X, right? X people. We know that the relative frequency is the number of people divided by the total number, right?
Mhm.
I know this number 0.375 must be X divided by 40, right? Everybody see that?
Mhm.
Now, if you want to get X by itself, you have to do exactly what Princess told me, right? Is it Princess? It's you, right?
Yeah, it's me.
Okay. But Princess told me if you want to get X by itself, you have to multiply both sides by 40, right? This is where the stuff comes from, okay? So you multiply both sides by 40, you multiply by 40, just to go out, so the number of people whose group is O is 40 times 0.0375, and you get 15 people when you do the math, right?
Where do we get the 40 from?
It's right here. 40 randomly selected blood, right?
Okay.
If you don't have that number, you cannot answer to this question. Basically, is a data will be missing. You know, if you don't see the 40, it means the problem doesn't have enough data, so we won't be able to answer. But since we have 40, I know the relative frequency is, for instance, here, if I say, how many people have out of group A, what you gonna do? To get the number of people of group A, what you gonna do?
40 times 0.475.
Exactly, 40 times 0.475, etc., etc. This is what you're gonna do to get that. So if you have relative frequency and you want to know what was the number, you multiply by the total number of people.
Total number. Got it. Okay.
So this is the one I have here. So do you have another one which is different? All right. So that's that is about this one right here. So we're gonna take a break, and when we come back from the break, we're gonna do the section 5.3. Okay, I told you these sections are very, very short sections. Okay, so in some of the textbooks they are just one section. We even don't divide them. Okay, section 5.3, which is organizing and graphing quantitative data. Now is not qualitative, is quantitative data. Okay, when you come back, we're gonna do that. Okay, let's take like about 10 minutes break, everybody.
I had to be the little rebellious cousin.
All right, so welcome back, everybody. So we're gonna start section 5.3, which is organizing and graphing quantitative data. Now, you know, we did the bar graph, the table of frequency, and the bar graph. That is designed, you know, that is if you have a qualitative data or categorical data. So now we're gonna see what are the ways to represent a quantitative data. Okay. So are we going to see what's going to be the challenges here? So for instance, this data right here is a commute time to school. The data below represent in minutes for a group of students attending a particular mathematics course, right? We would like to create a frequency table, you see? So these are not categories, okay? If you want to create a frequency table, right? So either you're going to treat each data as a category by itself. You see how many rows you're going to have? As many rows as data, right? You will have one row for 10, one for 15, one for 17, etc., etc. Imagine if you have like 100 of them, okay? So that is not very practical. We don't have like categories like the other ones. Since we don't have categories, we're going to try to create categories for this type of data, which make more sense to represent in a frequency table. It's going to be very overwhelming if you have like some data that can be like, you know, that can be continuous. You see, it's very hard, you know, to represent each one of them, because if you treat each one of them as a category by itself, then you know, it's going to be very, it's going to be overwhelming. What you're going to do here, we're going to create categories, okay? We're going to create them. We don't have categories. So what you're going to do is, we're going to create categories. Right? And in this context, we call them classes, okay? We call them classes. So basically, we're going to create categories that we call classes, right? So in order to avoid having each data to be a category by itself, to avoid that, we're going to say, okay, this group of data, they form a single category. These groups form a single category. These groups form a single category, right? For instance, when you look at grading, how many categories do we have in grading? So, you know, the final grade, we have only 4 categories, right? We have 0 for OED3 class. We have 0 all the way to 69 is one category, is a F category, right? We have 70 all the way to 79 is one category. This is a C category. right? We have 80 all the way to 89 is one category, is one class. This is a B class. And we have 90 all the way to 100 is an A class. But the only difference between that and here, the classes we're going to create, they will have the same width, the same size, okay? Unlike the grading stuff. The grading, the categories don't have the same size. Here, we're going to create classes that have exactly the same size, and we choose the size of the class, okay? We're going to choose the size of the class. Of course, you know, imagine somebody is working with like a data where you have 1 million data, the size is 1 million. They have to choose like a very good size that's gonna help them represent that data. Okay, here we don't have all that. You know, this is not like 1 million. It's only this set of data. So we're gonna create classes. So we're gonna choose the size of the class. And the lower limit of the first class. Okay, so we're going to choose the size of the class. It is our choice, and the lower limit of the first class. Let's say, since I see here, what is the minimum number of minutes here?
5.
Is it 5? Do you have a minimum? I think it's 3, right?
Oh, 3. You're right. I'm sorry.
3 minutes, right?
Mm-hmm.
And the minimum time is 3 minutes. So our first class, we can choose to start at 3, right?
Mm-hmm.
That is a choice. But 3 is not like really a nice number, okay? So why not start at 1 minute, okay? But again, that is a choice. If you want to, you can start with 3, okay? If you want to, you can start with 3. And then it's going to be of size 10, right? So my first class will be, let me choose the first class. My first class, let me choose the lower limit to be what you call 1. And the upper limit, since it should be of size 10, the upper limit is 10. 1 to 10, that is size 10. So now, so my first class is going to be 1 minute. Everybody that have a commit time of 1 minute all the way to 10 minutes will be counted in the same category, a single class, right? That is one category. Everybody that has a commit time of 1 minute up to 10 minutes will be counted in the same category. So now, look now, very important now. If, naturally, if it says this, one class is from 1 to 10, right? If somebody asks you what is the size, what you would do? If you look at the numbers 1 to 10, what you would say is the size? You would say is how much, the size? Me personally, if I have never seen the concept of class in statistics, if I have never seen that, somebody show me 1 to 10, I would say the size is 9, right?
Mhm.
I would do 10 minus 1, right? Okay, that's the first thing we have to learn. The size of the class is not the upper limit minus the lower limit. That is not the size of the class. You see, 10 minus 1 is what? It's 9, right? What you say the size was? We say the size, we're going to choose the size 10, right? You see, where we get 10? If the first class is from 1 minute to 10 minutes, right? What's going to be the second class then? From what to what?
10 to...
No, the 10 minutes is already taken. From what minute?
So it'll be from 11 to 20?
11 minutes to 20. And where do we see the size of the class? Where do we see the size when we subtract these two? What is 11 minus 10? 11 minus 10 is, what is 11 minus 1?
10.
Is 10.
10.
The size of the classes is the difference between 2 consecutive lower limits, okay? The size of the classes will be the difference between 2 consecutive lower limits, or the difference between 2 consecutive upper limits, okay? But it's not upper limit minus lower limit. Do we agree with that, everybody? That is a common source of mistake, okay? When you say the size of the class, you don't subtract the upper limit. You don't do upper limit minus lower limit. You don't do that. The size of the class involves 2 classes, okay? 2 consecutive classes. When you subtract the lower limits, that gives you the size. When you subtract the upper limits, that gives you the size. You see, what's going to be the next class? What's going to be the third class? From what to what?
21
to what?
21 to
30.
30. What is 21 minus 11? 10. What is 30 minus 20? 10, right?
10.
Exactly. So the size of the class, or the width, do they use this word size or width? Let me double check. It is the same thing. The width, okay. The width of the class, right, of the size of the class, which is the same thing. It's going to be equal to the difference between 2 lower limits or the difference between 2 upper limits, okay? So that is the width of the class. The size of the class or the width of the class is right, is equal to what? The difference between 2 consecutive lower limits, right? Or difference of 2 consecutive upper limits. Okay, that is the difference of, that is what you call the width of the class, or the size of the class. Is the difference between 2 consecutive lower limits or 2 consecutive upper limits, right? So now if you want to do that now, if you want to represent my classes now and do a frequency table, what I do, so now I do my classes right here. I have, that is the classes. 1 to 10, 11 to 20, 21 to 30, right? 31 to 40. I have to go until I cover all the data. What is the maximum data we see here?
60.
60. I have to go all the way to 60, right? 41 to 50, and 51 to 60. Okay? And the frequency here is, you see, that is the frequency. Now we're going to count how many numbers between 1 and 10 for the first class. How many you see? You see, let's round them with a blue. We already rounded 3 with blue. Let's circle them with blue stuff. We have 1 here. 10 is counted, right? 10. 1 here, 2 here, and then we keep going. 3 here, right? We keep going. 8 here, okay? And then 10 here. How many? The frequency is
5.
5, exactly.
Wait, well, I'm confused.
You confused with what?
Wait, so are you counting how many numbers is between 1 and 10?
Yes,
Okay.
including 1 and including 10.
Okay.
Including both of them. That's it for the first class. The first class has a frequency of 5. And everybody, do you see why it's very important to divide my data into classes? These are quantitative data, you know. Imagine this is like a very small size of data. Imagine you have 500 of them. Can you represent a table with 500 rows? Potentially 500 rows? No. That is, that is not practical in science. In science, people who do research, they cannot spend all the time just doing the representation of things, right? So they have to find a very effective way to represent data. And here it does help to group the data into categories. And by doing that, you will not lose, you will not lose the meaning of, what each set of data means. You will not, of course, of course, there will be, what classes am I going to consider? Of course, it's going to be, for instance, we are trying to study population, right?
Mm-hmm.
We know the population, the age vary from zero year to, let's say, 100 years, right? Okay. So is it practical to treat each year as a category? That is not practical. How many rows are you going to have? 100 rows, right? Okay. So now, I think if you want to study population, that you can divide them into a class of ages. For instance, when you say, okay, I'm going to take everybody from baby, newborn to 5 years as a category, I don't think you're going to lose any generalities. I think those people, we can group them into a category without losing any, because they're all kids, right? If you choose everybody from 20 to 25 as a category, I don't think you're going to lose any type of gender, because those people, they can be represented, they have the same population. You see, so dividing into classes is very helpful, but we have to find a smart way to choose the classes if you were really doing the statistics. Okay, now we are doing something that doesn't mean anything, right? But if it was something that really means something, then we have to, the choice of the classes is crucial. All right, so now 11 to 20. Let's circle them with another color. 11 to 20. I have 15, right? I have 17, right? I have 20. I have 20. 17. 15, right? 18. 14. A lot, right? So we have 15 right here. That's it, right? How many circles we have?
10.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10. That is 10 right here. Okay, that is 10. Now 21 to 30. And then we take another color. 21 to 30. We have 25. We have 30, right? We have 30. We have another 30. We have 22. And we have 25. We have 25, right? How many we have?
6, 7.
It's like 7, right? We have 7 over.
7.
31 to 40. Let's take another one. See, me, I do not run out of colors. I have a lot of colors. So yellow. Okay, we said 31 to 40, right?
Just one.
Just one right here, right? That's a 38. We have just one. And then 41 to 50. 41 to 50, do you see any?
Nope.
No.
0, right? And then 51 to 60, we have
1.
1. You see, and now we're going to add our frequencies, and we're going to see if it has equals the size that we see over there. So when we add them up, we have 15, 22, 24. 24 students, right? So do we have 24 right here? This table right is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times is 24, right? So very likely I am right. Very likely. Okay, I am right. So now that is the frequency table dividing into classes. Now, what is the relative frequency? Same thing. This stuff doesn't change. For the class 1 to 10, the relative frequency is 5 over 24, right? Which is how much? 5 over 24.
21%.
it gives about 20.833, right? 20.83%. Or, I mean, you can write all 0.208. Okay, and then this is 10 over 24 for the next one, 10 over 24. That is 41.6667, right? This is 0.4167, which is about 41.67%. This one is 7 over 24. 7 over 24, which is 29.16% or 0.17. This is 0.2916, which is 29.16%, something like that, right? And then 1 over 24, 1 over 24, which is 0.04167, right? Which is about 4.16%. And finally, this is 0, which is 0%, right? And this is the same thing, 1 over 24, which is about 0.416, and which is 4.16%. Okay, so again here, the frequency, you know that. The relative frequency, we know that. Here, what we are learning is how to construct, how to do your classes. Again, the size of the class, usually we give you the first one and we give you the size. The size of the class is the difference between two lower limits, or the difference between, basically you need to have two classes. You need to have two classes to do the size, basically. All right. So now, what you're going to do for this one is what you call a histogram. A histogram is basically a bar graph, but the histogram is only for quantitative data. It's a bar graph, but only for quantitative data. That is histogram. It's a bar graph only for quantitative data. So what is needed for histogram? That is needed for histogram. Right here. If you want to do the histogram, again, histogram is only for quantitative data, for numbers, the data that are real numbers, okay? What you're going to do, draw the horizontal axis with the lower class limits equally spaced along it, okay? Draw the horizontal axis with the lower class limits equally spaced along it. Only, look right here, only the lower class limit will be represented right here. So we're going to do that. We're going to do exactly what they tell us to do. What they tell us to do. So I'm going to draw horizontal axis like this, okay? And I'm going to represent. You see, the vertical axis right here is that will represent the frequencies, okay? We know that. But here, I'm gonna draw your attention to the horizontal axis. This is where you put the classes. We're gonna put exactly the lower class limit. They go from 0 is 1 is the first lower class limit. And what is the next one? Is 11, right? 1 to 11, and then 21, 31, and then 41, and then 51, right? These are the lower class limits. They represent like this, okay? That is a representation that we chose for this histogram. Of course, you know, there is, you know, a little discussion, you know, whether this is like not very confusing, etc., etc. But this is a representation right here. And of course, here we're going to do the frequencies. So we have frequencies. We have the highest one is 10. So we can take like, you know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? The first class is 1 to 10 is the frequency 5, right? That is the first bar we're going to draw. 5 is here. 1, 2, 3, 4, 5. That is 5. See that? That is the first bar. The second class is, the frequency is how much? Is 7, right? I mean, it's 10. That is the second one, is 10. The second one is 10, so we do, you see, is this. They all adjacent. You see, the bars are adjacent. That's second one, 10. The third one is how much?
7.
Is 7, right? Is 7. 5, 6, 7. That is the third one like this. The next one is how much? 1.
Uh-huh.
Yes.
The next one is 0. And then the last one is also 1. You can do until 60, right? Because that is the last one. That's the last set of data, or 61, right? You know, it doesn't matter, okay? 51 to 60. That's the last class, okay? $61. All right. So these are. So now, is this really ideal? This is a really ideal representation, but we have to compromise. Look right here. Normally, the first bar, if somebody never seen that, somebody never seen something like that. I never seen statistics. I don't know what a histogram means. I have no idea, but I know how to read graphs, right? Because I did math. I know how to read graph. If you show me this graph, I would say naively, the first bar represents numbers from 1 to 11. I would say that, you see? Okay? If you tell me that, I'm going to say the first graph represents 1 to 11, okay? But that is not the case here. The first bar represents 1 to 10, the number that we don't see over there, right? You see, we don't see 10, okay? We have to agree that these numbers, 1, 11, 21, 31, 41, etc., they are lower limits, okay? Which means here what we represent here is the lower limit of each class, what we represent, the lower limits, okay? So this is not an ideal representation. We have some other representations, etc., etc. You know, some other representation of histograms. We have a long discussion. What are the best numbers to put there? You know, we have a long discussion. We don't go over there. For our class, we just agree that when we represent histograms, we put the lower class limits, okay, for our class. When we represent histograms, we put the lower class limits. Agree with that? Okay, so now we're gonna go ahead and try to see how to draw, how to make classes and then do the whole thing. Make classes and then do the whole thing. So let me do this. So, all right, so let's do this. Let's pick a problem right here from my open math. From the book, and see how we're going to do that. Okay. This one right here. So we have a teacher. Okay, so we have this, and then these are the questions right here. These are the questions. All right. Right here, everybody see that?
Yes.
Everybody see that? Okay. So we have a teacher at your college selected a group of students from all of his classes and asked them the number of credits each took that semester. And that is the answers right there. Create a frequency and relative frequency table to display the data. Okay, now look now. Let your first lower limit be 3 and the class width be 3 credits. Let your first lower limit be 3 and the class width be also 3. So basically you're gonna do that, you're gonna do this. You're gonna do the classes here. And here's the frequency. And here's the relative frequency. What they say is the first class start with 3. You see, they told us that, so I don't have to choose anymore because I was told to choose the first one to be 3. Go ahead, try to complete your classes according to exactly what you did. Go ahead. First, do your classes first, and then yes. All right, for the classes right here, the size is 3, right?
Mm-hmm.
Okay,
Yeah.
so what is more safe? Is it more safe to figure out this number? Or is it safer to figure out the next class lower limit? What is safer to avoid mistake? What is safer to avoid a mistake?
I asked him, could I say the question?
Eh?
I didn't ask him about the classes. I asked him about the question.
He said the class is not here.
I didn't ask him that.
Yeah, the classes. So you have a question?
Yes, I was asking. I couldn't see the actual question. I wanted you to move it up a little bit
Okay, this one right
to
here.
understand.
This one right here.
Yes, thank you.
Yeah. So now I was saying now, okay, the first class, I think in my opinion, is safer to figure out what is the second lower class right here.
Mm-hmm.
I think it's safer because the width is going to be the difference of 2 consecutive lower classes, right? That's going to be the difference. That is the definition of the width. Now, when you say the width is 3, it means whatever number is here, when you do that number minus 3, it should be equal to what? It should be equal to 3. Okay?
So then that would be 6.
That number will be 6. You see, it's easier that way, I think.
Oh, okay, that's how I did it. Okay.
It's easier that way because it's very easy to avoid mistakes. You know, it's very easy to put 6 here. It's very easy to put 6 here. We put 6 minus 3 is 3. That is not the definition of the width. Okay? The definition of the width is the difference between these two numbers. That number that we, below minus 3. And that number should be 3 because we said the class width must be 3. So then 6 minus 3 is 3. So that is 6. Now that I know this is 6, then it's going to be, what number is going to be here then?
7 and 10.
It would be
what number is going to be here?
3 to 5.
3 to 5, exactly.
And then 6 to 8, 9 to 11.
And then 6 to 8, right?
Then
the next one is going to be, this is going to be here, 9 here.
9 to 11.
It's going to be here, 12 here. You see, you have to keep adding 3s. 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12. 12 plus 3 is 15 until you cover the whole data. What is the maximum number?
14.
Right? We have to keep going, right? Or this one goes on up to 14.
It
so
goes up to 14, yeah.
Okay, we can supply here. So 9 to 11, right? And 12 to
14.
12 to 14. Might see that?
Mm-hmm.
Exactly. This is how we do the classes. Okay. So I think, like I said, it is safer, to figure out the 2 consecutive lower limits and then go from there. Right? This is 6 here, and this is 5. So now, what is the frequency of all the numbers between 3 and 5 included?
1.
Only 1? Okay. So between 6 and 8?
8.
You got 8. 9 to 11?
12.
12. 12 to 14?
3.
3. Thank you. So the total number is 24. They like 24, okay? So the relative frequency which is going to be 1 over 24, 8 over 24, 12 over 24, and 3 over 24. And then we use calculator to get exactly those numbers, all right? Okay, so I need, since they're asking this, I need to go to the decimal numbers. 1 over 24 is 0.416.
416. 0.0416.
0.0416. 8 over 24 is?
I have a question. So
yeah, go ahead.
For the first one, I got 0.04166666. So I just rounded up. So I got 41.7%. So I rounded up.
Yeah, that's good. Yep.
Okay.
Yep, that is good. So this is 0.333, right? Okay, and here, so we're gonna just go use two decimal numbers, just to simplify stuff. We're just gonna round it like this. Okay. So and then we have 12 over 24 is 0.5, and 3 over 24 is 0. What? 125.
125.
Okay. So now our frequency table for the classes, we do this, and here we just put the lower limits, which means we're going to put 3, 5, right? Okay, is that right? I mean, not 5, I'm sorry, 3, 6 here. Is that right here? Am I right so far? What's wrong? What is wrong? If I do something like that, what is wrong? I mean, what's wrong here is
It's got a
This-
9.
This must be equal to this, right? You see how far the 9 is? 9 is the next lower limit. The lower limits are 3, 6, 9, and 12. If I put 9 here, then I'm wrong. You see, this distance must be equal to this distance. That is 9 here. Everybody see that? Okay, that is wrong there. So I don't put 9 here, so I put this 3, 6, and then 9 here, and then 12, and then 14. I mean, 12 plus 3 is 15. Okay, I put all the lower limits. So because the next one to come would start with 15, right? That's why we have 15 here. 3 to 6. What is the frequency? Is 1. So here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? That is 1. So I have 3 to 5. I have 1. 6 to 8 is 8. So 8 is here. 1, 2, 3, 4, 5, 6, 7, 8. That is 8. The next class is 12. All the way. That is 12. And the next class is 3. That is 3. This is frequencies. And we put here frequency. And that is the class. All right? All the time. Now, if we want to use the relative frequencies now, if you want to use the relative frequencies, it's the same thing. You see, it's the same thing. Basically, what is going to change between the histogram for frequencies and the histogram for relative frequencies? What is going to change? Tell me. What's going to change? Can somebody tell me what's going to change?
No, Professor, I can't. I can't tell you. I don't know.
The only stuff that's going to change, because the classes are still the same classes, right? The only stuff that's going to change are the units on the vertical axis. You see here we have what? We have 1, 2, etc. That is 12, right? If you want to do the classes for the relative frequency, we will have the same classes, but the only stuff that are going to change are the frequencies. I mean, as the units. Okay, now we don't have 1, we don't have 2, we have 0 point something. Okay, so if we do this, we do this, we're still going to do here 3 here, we're still going to do here 6, we're going to be a 9, it's going to be 12, and here 14, right? Okay, I mean 15, I'm sorry. So, but now here, the lowest frequency is 0, and the relative frequency, they're all decimal numbers, and the biggest one is 1 right here, right? So here we have 0.5, you see? Here we have 0.1, okay? 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, you see? 0.9, and then 1. I mean, the only thing that's going to change here is annoying now, because those numbers are not nice at all, right? The first one is 0.04, right? 0.04, it's going to be very approximative, right? This is 0.04 right here. Okay, the second one is, we're going to round, is 0.33. Is 0.33, is something like that. The second number, the last number is 0.5. Okay, that one is nice. It's 0.5. It's exactly this. And the last one is 0.125. You see, 0.125 is very hard to put if you're not a machine, right? Okay, that is the only difference between the histogram for relative frequencies and the histogram for frequencies. It's just the the units on the axis. Look right here, we represented the decimal numbers. If you want to represent the percentages, you have to make it known. You have to make it known that you are representing percentages. You have to say it. If you don't say it, we're going to take them as numbers, right? Okay. All right. So that's that. So let me see another problem. Okay. So now, I mean, let me see another problem that. Okay. Why not take one of the first ones right here, and then you're going to try to do it. All right. Look at this and try to answer to these questions. All right. So tell me, how many employees participated in the survey? How many?
55.
55, right? Everybody got 55? Okay, 55. What is the class width? What is the class width?
5.
5.
Exactly. It's 5, not 4, right? It's not 4, it's 5. It's either 6 minus 1, or 11 minus 6, or 16 minus 11, or 21 minus 16, or 26 minus 21. They all give you 5, 5, 5, 5, right? The lower limits are, of course, 1, 6, 11, 16, 21, 6, 26. And the upper limits are 5, 10, etc. Okay? So this gives you the vocabulary about that. Okay? So now we have another. So everybody, you see this right here. So we have some vocabulary about the shape. Do you see my PDF file here of this discusses the shape of histogram? You see that, right?
Yes.
Okay. So we have some vocabulary going on. For instance, every time we look at this histogram, we want to describe it. What is this histogram? We have some words. What is the shape of it? For instance, when you look at this histogram, I see only one peak, right? One peak. Everybody else is around. We have one peak, and we can describe this as a single peak. We call this unimodal histogram. We have one peak. Okay. If you have two peaks, when you say two peaks right here, look, why this one is considered to be a peak itself? Why? Why is this one right here? Why is this one is considered to be a peak? Okay, let me, so I can write only on top of it. This one right here. Why we consider that this one is, this histogram is bimodal? Because we call it as two peaks. Okay? Why we consider this one is a peak and this one is a peak? You see, they don't have the same height, right?
No.
But they are far away enough, so everybody represents a peak in his neighborhood. Okay, everybody, they are enough far away from each other, so each one of them is a peak in its neighborhood. Okay, it's like if you have you have one tall building in Owings Mills, and we have one tall building in Towson, you can consider you have two tall buildings, okay? Everybody is a peak. But when you put them one next to another, if the other one is way, way higher than the other one will not be tall anymore, okay? So this is why here, look, why here, this one above, why we say this one is only one peak? Because the next one that is taller is right next to it, right? You see that? The next one that is taller is right next to it. The next one is tall is right next to it. So this one is a unimodal histogram. But this one is a bimodal because the next one, it is taller, is far enough from that one right here. So that's a bimodal. And if you have more than two peaks,
Wait,
if you have like,
explain that one more time.
This is what I was saying. You see here, if you change this one, if you do this, if you change this one right here, if you do this, and then we do this, and then we do this, if you put them next to each other, then it is no more bimodal, it's only one peak. Because the next one that is tall is right next to it. It is in his neighborhood, right?
Oh, okay, I get what you, okay, that, okay.
They have, for
So
each one of them,
they have to be a little bit spaced out in order.
exactly, they have to be a little bit spaced out. So each one of them is a tall building in its own neighborhood, right?
Okay.
So this is the reason why this one is called a bimodal. If you have more than two modes, if you have like, you know, this one here, we have this one is a tall one, and then we have this, and then we have another one which is a tall one right here, and then we have this, and then we have another which is tall. So how many peaks we have here? 1, 2, 3 peaks, right? This is like we have multimodal. That is just for some vocabulary, okay? This one is unimodal right here. Just for some vocabulary. Now we have another vocabulary.
I have a question.
Go ahead.
What if what if it was just one spaced apart, like not two? Like, what if it was just? Would that still be a bimodal?
Yeah, I mean these are not very absolute.
Okay.
The description is not very. I mean that's a very good question. It's not like absolute, like 1 + 1 = 2. It's not, you know. It's like, you know, subject to discussion. We can discuss about. We can say, okay, I mean the neighborhood. We can say this one right here is really, you know, unimodal stuff because So that is why we don't base a lot of calculations on that. Okay, what we base on is, I mean, we can try to understand the data based on that, but the calculations they have to be more rigorous than that.
So the multimodal is more than 2.
Yes, more than 2. If you have 3 more, 3, 4,
3 or more.
but even two is a multimodal. I mean, 2 bimodal is also a multimodal. You know.
Okay.
All right. So right here we have another vocabulary going on. So sometimes we say, for instance, this one right here, this histogram right here that you see, is we can see it as something like symmetry. In math, what we say symmetry is we have one axis and the one side is almost equal to the other side. It's like, you know, the red line is like a mirror. Of course here, this is not exactly, you know, the right side and the left side are not exactly the same bars, right? Are they exactly the same bars? They are not exactly the same bars, but they almost same bars. They follow the same pattern, you see? They follow exactly the same pattern. Okay, they are not exactly the same bars, but when you look at the left and you look at the right, we almost see about the same thing. We can call this one a symmetric histogram. Now, is it perfectly symmetric? It is not perfectly symmetric, right? What is perfectly symmetric? The perfectly symmetric is something like that. It's something like, you know, I have this, and then I have exactly same stuff right here. You see? Exactly same stuff right here. Exactly same stuff. This one is perfectly symmetric, right? When you fold this one in the middle, it does fold perfectly. But in the context of histograms, even if when you fold it, you see a difference between the bars right here, if that difference is not like very, very exaggerated, we can say that, you see the word almost right here, almost match. When you fold in the middle, if they almost match, then you can say this is symmetric, okay? It's not absolutely symmetric, right? The absolute symmetry, it means really when you fold them, they match exactly, bar by bar. But here, they don't match exactly, but they almost match. We call that a symmetric histogram. Again, this goes into trying to describe the histogram, trying to describe the data, right? Okay, now if you have this one right here, you see after the peak, when you have the peak, where you have the most data, you have most data to the left side, right? From the peak, most data to the left side. This is called skewed left. This histogram is skewed left. This one right here, after the peak, from the peak, the most data is to the right. This is skewed right.
Okay, let me write this down.
Yeah, this is just, some vocabulary going on, right? You see, the skewed left, if you call it like something like a tail, the tail is on the left side, okay? The skewed right, the tail is on the right side. That is also for the vocabulary stuff. So now look, if you do this right here, I'm gonna show you some histograms. This one right here. You see, just to show you, nothing is absolute here. What do you think, number 7? What do you think this one is? Is it symmetric? Is it skewed right, or is it skewed left? What do you think?
Skewed right.
Symmetric?
Everybody would say, personally, including myself, I would say this is almost skewed right.
Yeah.
But let's go to the answer key. The answer key says it is symmetric. You see?
Yeah.
Somebody said symmetric, right? The answer key said symmetric. But if it was absolute, all of us will have exactly the same answer. If this was absolute answer, all of us will have exactly the same answer. We would say symmetric.
Wait,
But
so
somebody can make
symmetric and not skewed.
Yeah, somebody can make when it is symmetric, it's symmetric. Symmetry means the left side is almost equivalent to the right side, okay? So it cannot be symmetric and then skewed. But just to tell you, this is not absolute. It's not like 1 + 1 = 2. you can spend like 5 hours arguing the case, okay? So that is why I will not ask those stuff on the test unless if it is clear. So this one right now, this one you can argue, this one is skewed right, okay? The one next to it, okay? This one right here. We can say this one is skewed right. So we can make that case. Okay, that's for vocabulary, of course, So then we have another way to represent the data. That way right here. That way is called dot plots. This is called dot plots. Okay? Look at how simple this way is. Basically, you put a horizontal line, you put all your data, so 1, 2, 3, 4 until 60, right? You put all of them here. Here they take units of 10, 20, 30. And then each data is represented by a dot above the number. You see, we have what? When you come back, we had how many times we have the data? How many times we have the data? 3. Only 1 time, right? 3 is only 1 time. Look at that point, that plot. We have 3 right here. You see 3? 3 is right here, 1 time, right? Okay, so let me put the data side by side so we can compare that. Let me put the data side by side so we can compare. That is another representation. We call that the dot plots. Okay, so we have insert this. That is the data right here. And then the dot plot, what you put? I put my numbers right here. I put this. I put my straight line like this, where I put all the data. I put 0 here, this is 10, this is 20, this is 30, 40, 50, 60, right? Okay, so now, 3, how many times I have 3? I have 3 one time, right? Where is 3? 3 is about here. 3 is about, this is 5. And this is like 3. What I put? I put 1 dot. Each dot represents a data. Okay, now I have 30. How many times do you have 30?
30.
1, 2, 3. Only 3, right?
Mm-hmm.
So above 30, we're going to put how many dots? 1,
3 dots.
2, 3 dots, right? Okay, 15. We have 1, 2, 3, right? 4. 15 is 4, right?
Mm-hmm.
4, 15. So 15 is right here. That is 15. So we put 4 dots like this. That's because the dot plots. That is another way to represent data, etc., etc. So 60, I have 60 is only one time. I put 1 dot above 60. You see, etc., etc. This is a dot plot. That is another way to represent data. Okay. So when you see that, sometime, somewhere, if you see that somewhere, it is a representative of quantitative data. Okay. So now another representation is the stem and leaf. That is the last representation we're going to talk about. But of course, I just want to talk about it. But this is not the focus on. You see, the frequency table is more likely that I'm going to ask. The frequency table is the representation that we're going to represent the most. The stem and leaf plot is another way to arrange quantitative data. The plot separate each value into 2 parts, right? The stem, such as everything on the leftmost digits, and the leaf, such as the rightmost digit. For instance, this is this data right here. Everybody see that? That is representation stem in leaf. This is the stem. The left side is the stem, and the right side is as the leaves. So for instance, let me take the first one. The first row represent what? The first row represent 0, 3. You see, it's going to be 0, 3. The first row is 0, 3, right? First is 0, 3. And then I have what? Then I have 0, 5. And then I have 0, 8. You see right here, 0, 3, 0, 5, and then 0, 8. Okay? Tell me, this one right here represent what numbers? How many numbers the second row represents? Tell me, how many numbers the second row represents? How many? The second row represents how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers. What are the 10 numbers it represents? 10, right? What is the next number?
10.
Another 10.
14.
And then 14. And then
15.
15. How many times 15?
4.
4 times. And then
17 2 times.
17 2 times. And then
18.
18.
the next row represent what numbers?
22 times.
It represent 22 times.
22. And then 25.
And then 22. And then 25 3 times. All right. And the next row represents what?
33 times and 38.
33 times and 38. The next row here, 4 has nobody here, right? Which means
0.
we don't have 40. We don't have anything like 40 something. There is nobody here, right? 50, we don't have anybody 50 something, nobody. And then the last one is 60.
60.
Okay. So this is what you call stem and leaves plot. All right. So these are representations, you know. But again, I repeat again, the one we're gonna ask on the test or on the exam as a frequency table. Okay. Do the classes and do the frequency table. That is the one you're gonna ask. All right. So that is what we learned. Now is how to do the bar graph. I mean, how to do the frequency table, how to do the relative frequency, how to write it as a percentage, how to do the bar graph, how to do the histogram. This is what we learn. These 5 things we learn, right? So now for the quiz, it's going to be on the factoring, right? It's going to be available, I think, as soon as we end the class, 8:30, I think. You will have until Thursday noon to to submit it. Look, this is your class right here. Quizzes, right? What do you see? Quiz number 3, available on November 16, 8:30 until November 18 at 12 o'clock. Not 11:59. It's only 12 o'clock. You hit this, you get the PDF file, you do what you have to do, and then you go to assignments and you go to submit your quiz 3 here. Okay? It's going to be on the factoring, basically. A quick survey of the factoring. How you factor x squared minus x minus, let's say, I don't know, minus 30. Somebody tell me, how you factor this one?
Parentheses x squared.
Parentheses, right? You put x here or you put x here. What are the 2 numbers? Go ahead. What are the 2 numbers?
X squared.
Now, when you factor this, you will be looking for 2 numbers. They must add up to what?
-1.
Add up to -1 and multiply to what?
30.
30.
Negative 30. What are they?
6 and 5.
Okay, who is negative, who is positive? Or are both of them positive? What are they?
No, +5 and -6.
+5, -6.
You should do not let this mic unmute. What the fuck?
Okay. Mute yourself, please. Okay, so x plus 5, x minus 6, right?
Yeah.
Yes.
Okay. So see, that's going to be on the quiz, everybody.
Okay.
Only something like that. Okay, not harder, but also not easier. Something like that. Okay, that's going to be on the quiz. That is factoring trinomials when the leading coefficient is 1. Everybody should know that because after the quiz, you have the test also, right? We should know that. So, and then the next one here will be factoring like something like x squared minus 25. Do you remember how to factor that?
X plus 5, x minus 5.
Thank you very much. This is a difference of 2 squares, right?
But can we, so we would have to do, so we can't do like x plus 5 squared.
It's different. You have the right answer. Don't make it wrong, right?
Okay, no, I know that was the answer, but I was just asking if the other one could be answered. But okay, thank you.
The other one is different. It's x plus 5 is minus 5. Everybody knows if you have like 49x squared minus 1, how you factor that? These 2, same category. Exactly. They factor the same way. 49x squared is the square of what?
7.
7x. And 1 is the square of what? 1, right? So what's going to be then?
7x
plus 1, 7x minus 1.
Exactly. You're going to see that something like that on the quiz also, okay? And on the upcoming test, you see? And finally, if you have solve x squared plus 13x plus 30 equals 0, right? You already have 0, solve by factoring, right? What you're gonna do, you're gonna factor this one stuff right here. You're gonna factor like this. Same way we factor the first example. What are the two numbers?
15 and 2.
15 and 2? I don't think so. Because 15 plus 2 is not 13.
10 and 3.
10 and 3, thank you.
Yeah.
Oh yeah.
It's not negative 10 and negative 3.
You see, if you say negative 10 and negative 3, they don't add up to positive 13, right? Whatever two numbers you put, make sure they verify the two conditions. They verify both conditions. They must add up to 30. They must multiply. They must multiply the 30. They must add up to 13. Make sure before you render your copy, make sure of that, right?
Okay.
Because once I got your copy, there's no changing, right?
Yeah.
You see? So now you said, are you done? In this case, when you say solve, are we done?
No.
We're not done. Every time we say solve, you have to go all the way until you get x equal. Then you're done. When we say factor, after you factor, you are done. You don't solve nothing. If you say factor, you don't solve afterwards. But when you say solve, you have to keep going. What we do x plus 10 equal to?
X equals 0, and then x plus 3 equals 0.
Equals 0. And then how we get x by itself in the first one?
Subtract 10 on both sides.
Subtract 10, you get x equal negative 10. And how you get x by itself?
Subtract 3 on both sides.
Exactly, x equal negative. That is what you're going to see on the quiz, everybody, okay? That is you're going to see on the quiz right after class. So please, the quiz is very important, right? Not as important as the test, but it's important because, it's important for the grade, okay? If you maximize your grade you can have on the quizzes, it does help, all right? All right, everybody. So we're going to dismiss the class today. When we come back next week, we're going to do the last chapter. We're going to start the last chapter of this class, right? Which is how to find the mean, the median, the mode, the standard deviation, etc. We're going to start that next week.
You'll have this one on YouTube, right, Professor? Because I think I might have to watch this one over.
Right here?
Yeah, I was saying.
I'm gonna post it on YouTube.
Okay.
Right after class.
I'll watch this one over and over. I'm a little confused, but I'll watch it over and over.
Yeah. So, and if you're still confused, you can come to office hours, okay?
Yes.
All right. All right, everybody.
All right.